Question 27E. Karen is in Athens, which is 2 hours ahead of Greenwich Mean Time. Marco is in New York, which is 5 hours behind Greenwich Mean Time. Part 1. Karen is going to ring Marco at 10 p.m. on Tuesday, Athens time. What day and time will it be in New York when she rings? So to help answer the question, I've drawn a number line, and on this number line I've indicated GMT, also known as UTC, and I've given that a value of 0, so that's in the middle of the number line there. Now Athens is 2 hours ahead of GMT, so Athens is written to the right of GMT with a value of +2, and Karen is in Athens. And New York is 5 hours behind GMT, so New York is written to the left of GMT, and I've given it a value of -5. And of course Marco is in New York. So the time difference between New York and Athens can be found by finding the time difference between New York and GMT. So between -5 and 0, there are 5 hours. And between GMT and Athens, there's another 2 hours. So 5 hours plus 2 hours gives us 7 hours. So Athens is 7 hours ahead of New York, or we can say that New York is 7 hours behind Athens. So Tuesday, 10 p.m. in Athens, if we subtract 7 from 10 p.m., corresponds to Tuesday, 3 p.m. in New York. So part 2, Marco is going to fly from New York to Athens. His flight will leave on Wednesday at 9 a.m. New York time and will take 11 hours. What day and time will it be in Athens when he arrives? So since we're interested in the time that he arrives and reference to Athens time, it makes sense then that the first thing we need to think about is to convert the New York time, or the time when Marco leaves, which is referenced to New York time, to Athens time. So Wednesday, 9 a.m. in New York, if we add 7 hours to that, that corresponds to Wednesday, 4 p.m. in Athens. So as soon as the plane takes off in New York, Corinne in Athens will look at her watch and go, oh, it's 4 p.m., the plane has taken off. And it's Wednesday, 4 p.m. in Athens, the moment the plane takes off. Now we're told here that the flight takes 11 hours. So now that everything is referenced to Athens time, all we need to do is just add 11 hours to this time here and then work out what day and time the plane arrives in Athens. So Marco leaves New York on Wednesday, 4 p.m. Athens time, and the flight takes 11 hours. Again, we can visualize this with a number line. Now I've drawn a slightly different number line here. So in the middle here, I've indicated midnight, 12 a.m. and it's Wednesday on this part of the number line. So this is Athens time. And obviously past midnight, it becomes Thursday. So Wednesday, 4 p.m., the plane takes off and takes 11 hours, obviously to fly from New York to Athens. So from 4 p.m. to midnight, that takes 8 hours. And from midnight plus 3 hours, so that gives us the total flight time of 11 hours, 8 plus 3, to give us our 11 hours, means that the plane will land in Athens at 3 a.m. on Thursday. So Marco lands in Athens on Thursday at 3 a.m. Athens time. Question 28C. A ship sails due south from Channel Port aux Basques, Canada, 47 degrees north, 59 degrees west, to Barbados, 13 degrees north, 59 degrees west. How far did the ship sail to the nearest kilometre? Assume that the radius of the Earth is 6,400 kilometres. Now the ship is sailing in a north-south direction, and we can see that by observing the longitude in both of these coordinates is the same. 59 degrees west, 59 degrees west. However, the latitude has changed. So we're starting off at 47 degrees north and ending up at 13 degrees north. So the ship is sailing along a great circle. So we need to know the difference between 47 degrees and 13 degrees. And both of these coordinates, of course, are in the northern hemisphere, since they're both north. We know that the radius of the Earth, or we assume the radius of the Earth, is 6,400 kilometres. So our first step is to determine the degrees sailed. So 47 degrees north minus 13 degrees north is equal to 34 degrees. Now, you just need to be careful that if this was 13 degrees south, this would need to be a plus sign. Now we need to convert this 34 degrees into a distance. And we need to take into account the circle that the ship has sailed on. So the distance sailed is equal to 34 over 360 multiplied by 2 pi, or 2 pi r, but multiplied by 2 pi multiplied by r, and we're told here that r is 6,400 kilometers, and this equals 3,798 kilometers correct to the nearest kilometer. Question 26G. Singapore is located at 1 degree north, 104 degrees east, and Sydney is located at 34 degrees south, 151 degrees east. What is the time difference between Singapore and Sydney? Ignore daylight saving. Now, time difference is dependent on the longitude, not the latitude. So the first coordinates are of no significance. It's only the second coordinates. So what I like to do is to represent those on a number line. So 0 degrees is the prime meridian. That's west, that's east. So Singapore is at 104 degrees east, so it's not to scale, but it just helps to visualize the difference. Sydney is at 151 degrees east. So the further east the location, the further ahead it is in time. Now, every 15 degrees longitude is equal to 1 hour time difference. So how many lots of 15 degrees do we have between Singapore and Sydney is more the question. So the way I worked it out is 151 minus 104 will give the difference in longitude, and then dividing that by 15, you get 3.1333 recurring, and then pressing the degrees, minutes, seconds button, that converts that into hours and minutes. So I'll just demonstrate that just to show you. So 151 minus 104, divide that by 15, press equals. Now pressing the degrees, minutes, seconds button, and the answer is in hours and minutes. Question 14. Stockholm is located at 59 degrees north, 18 degrees east, and Darwin is located at 13 degrees south, 131 degrees east. What is the time difference between Stockholm and Darwin? Ignore time zones and daylight saving. Now, the first thing to note is that time difference has nothing to do with lines of latitude or parallels. These are the first numbers, or the first in these pair of coordinates. So you could in fact cross these out. So the 59 degrees north, 13 degrees south has nothing to do with time difference. It's purely the difference in longitude, or the difference in the meridians. Now the next thing I'm going to do is to draw a number line to visualize this. Okay, so let's make this 0 degrees, so that's our prime meridian. Stockholm is 18 degrees east, so there's east and west, so I'll just mark that on the number line. Okay, so there's 18 degrees, okay, and that's Stockholm. And Darwin, okay, is 131 degrees east. So that would be here, 131 degrees east, and that's Darwin. So let's work out, first of all, the difference in longitude. Okay, so Stockholm is closer to the prime meridian. Okay, that's the meridian that runs through England, or not far from London, actually through a town called Greenwich. That's why it's used to be called Greenwich Mean Time, GMT. Okay, so 131 minus 18 gives us 113 degrees difference. Now, it's well worth noting, if you haven't worked this out, or you could work this out if you like manually, but I guess it's just well worth remembering this one. Every 15 degrees difference in longitude is equal to 1 hour. So the time difference will be 113 degrees. Now divide that by 15, because every 15 degrees is equal to 1 hour. And let's see what we get there. So 113 degrees divided by 15, and we get 7.5333. In fact, let me just convert that into a fraction. So it's 7 8/15 of an hour. So equal to 7 8/15 15ths of an hour. Now, in minutes, okay, we could multiply that by 60. And we get 452 minutes. Okay. And there is an option for that, which is option C. Question 26C. Two cities lie on the same meridian of longitude. One is 40 degrees north of the other. What is the distance between the two cities, correct to the nearest kilometre? And assume that the radius of the Earth is equal to 6,400 kilometres. Now, first thing to note is that a meridian, or a meridian of longitude, is a great circle. So it's the circle of greatest circumference that really wraps around the Earth. And the radius of that circle is 6,400 kilometres. So the distance is going to be 2 pi r, so the circumference formula, okay, multiplied by 6,400 kilometres. But what fraction of the circle are we talking about? We're talking about 40 degrees out of a total of 360 degrees around a full circle. So we need to also multiply that by 40 over 360. Okay, and it says to the nearest kilometre, so just keep that in mind. Okay, so 2 pi multiplied by 6,400 kilometres. Okay, so that little detail needed to be given there. So in the old syllabus, or the previous syllabus, that was I think that was supplied in a formula sheet. So I think to answer this question in the current syllabus, we need to be given some details. Okay, and we get 4,468 kilometers to the nearest kilometer. Question 27E. Melbourne is located at 38 degrees south, 145 degrees east, and Dubai is located at 24 degrees north, 55 degrees east. Calculate the difference in longitude between Melbourne and Dubai. So longitude is the second coordinate. So 145 degrees, so we take the larger minus the smaller. Okay, so 145 east minus 55 degrees east is equal to 90 degrees. Okay, so if you just want to see this quickly in a number line, and I think it's good to see this, you don't have to do this, okay, but if that's the prime meridian, okay, so PM, prime meridian, 0 degrees, there's east, there's west, okay, there's 145 degrees east, and there's 55 degrees east. So it's what we want is the gap between these two, which is going to be 90 degrees. Part 2. Show that the time difference between Melbourne and Dubai is 6 hours. Now, the Earth rotates a full 360 degrees in 24 hours. So how many degrees does it rotate in 1 hour? Okay, so 360 degrees divided by 24 is 15 degrees. So think of the Earth kind of sort of spinning, you know, every hour, 15 degrees, another 15 degrees, another 15 degrees. So 15 degrees per hour. Okay, we have 90 degrees in total. So 90 divided by 15 is equal to, okay, 90 is equal to 6 hours. Okay, so there's a 6 hour time difference between Melbourne and Dubai. Dubai would be behind, or Melbourne would be ahead of Dubai by 6 hours. Part 3. A plane leaves Melbourne on Friday at 11:30 p.m. So that would be local time, of course. The flight time to Dubai is 15 hours. What will be the time and the day in Dubai when the plane is due to land? So answering a question like this, just work with in one time zone and then convert it to the other time zone at the end. So let's reference Melbourne as our for all our times. So a plane leaves Melbourne 11:30 p.m. Flight time to Dubai is 15 hours. Okay, so 11:30 p.m. on a Friday. Okay, and we're going to add on 15 hours. Okay, so 11:30 p.m. Now this is how we can do this. If you want to use 24-hour time, you're welcome to do so. I'm going to use 24-hour time. So 23 hours 30 minutes. I'm going to add on 15 hours. Okay. We get 38 hours and 30 minutes. Now that's clearly over 24. So if we subtract 24 hours, it's going to be 2:30 p.m. but the next day. Okay. And that's Melbourne time. So what would the time be then in Dubai? So the plane will land at 2:30 p.m. Saturday, Melbourne time. So the time and day in Dubai will be 2:30 p.m. Okay, minus 6 hours. You can use 24-hour time, so 14:30 minus 6. Okay, so 14 minus 6 is 8, so it's going to be 8:30 a.m. on Saturday. Question 27D. Island A and Island B are both on the equator. Island B is west of Island A. The longitude of Island A is 5 degrees east, and the angle at the center of Earth O between A and B is 30 degrees. Assume radius of the Earth is 6,400 kilometers. Now we need to add this assumption in because this is the question from a previous syllabus. So in order to make it a bit more accessible and be able to answer it with our current syllabus, we need to state this assumption. Part 1. What is the longitude of Island B? So Island B is to the west, which means that in order to find the longitude of B, we need to subtract 30 degrees from the longitude of Island A. So Island A is 5 degrees east, okay, and we treat east as a positive, and we're going to move in the negative direction, 30 degrees, and that gives us negative 25 degrees, and we treat negative 25 degrees as 25 degrees to the west. Part 2. What time is it on Island B when it is 10 a.m. on Island A? Now again, because we're moving in a westerly direction, the time on Island B is going to be behind the time on Island A. But what we need to work out is what 30 degrees represents in terms of hours, given that the Earth takes 24 hours to rotate through 360 degrees. So let's work out what 30 degrees represents in terms of hours. So 30 degrees out of 360 degrees, that's the fraction of the full circle, multiply that by 24 hours. How many hours does that represent? 30 divided by 360 multiplied by 24, and we get 2 hours. So the time on Island B is equal to the time on Island A, which is 10 a.m. Subtract 2 hours time difference, and that gives us 8 a.m. on Island B. Part 3. A ship leaves Island A and travels west along the equator to Island B. It travels at a constant speed of 40 kilometers per hour. How long will the ship take to arrive at Island B? Give your answer in days and hours to the nearest hour. So the first thing we need is this arc length, AB, and we need to use our assumption here that the radius of the Earth is 6,400 kilometers. So I'm going to add that on the diagram. Okay. And we're going to treat OAB as a sector of a circle, Because we're dealing with the equator. And the equator is what we call a great circle. So it's like a full circle, or the maximum size circle that basically goes around the Earth. Okay. Well, it's one of several great circles. That's the main one. That sort of goes around the Earth. Okay. So let's work out the distance first. Okay, and we're going to use the circumference of a circle formula, which is 2 pi r. So 2 pi multiplied by 6,400, but then we need to multiply it by the fraction of the circle that we're dealing with, which is 30 out of 360 degrees. Okay, so let's enter this in. So 2 pi multiplied by the radius, 6,400, multiplied by the fraction of the circle, 3,351 kilometers. Well, I'm going to round it to maybe, I might just write the full answer, 0.32164. Okay, just in the interest of maintaining some accuracy. Now, the time it takes for the ship then to travel this many kilometers, so is given by the distance, so 3351.032164, divided by the speed of the ship, which is 40 kilometers per hour. Okay, so I'm just going to use the previous answer on the calculator. Okay, so it helps not to clear the screen sometimes. And you get 83.7758.041 hours. 83.7758.041 hours. But we want the time in days and hours. So in order to convert that into days, we're going to divide that by 24. Okay. So it's important to show you working. Okay. And we've already worked that out, which is 3.490658504. Okay, days. So that's, in fact, in terms of days and hours, that's equal to 3 days plus, now, 0.49065 and so on, we need to convert this decimal part here into hours, because that's still in days. So that's going to be 0.490658504, multiply that by 24 hours. So that's equal to 3 days plus, okay, so what I'm going to do is just a bit of a shortcut. If you subtract 3 from that, that gives you just the decimal part. Multiply that by 24, and we get 11.7758 hours. And rounding that to the nearest hour, because that's what the question asks for. Okay, so that's equal to 3 days and 12 hours. Question 24. Now this question has a modification because it comes from an older syllabus. The coordinates of City A are 39 degrees north, 75 degrees west. City B lies on the same longitude and is 5,700 kilometers south of City A. Now we're going to assume the circumference of the Earth equals 40,000 kilometers. What is the latitude of City B? So we need to work out how many degrees City B is south of City A. We know that it's 5,700 kilometers, and we know that the circumference of the Earth all the way around is 40,000 kilometers. So we need to work out what that equates to in degrees. So 5,700 kilometers over 40,000, and then we're going to multiply that by 360 degrees, because that's how many degrees around the Earth all the way around. Okay, so 5,700 over 40,000, and we're going to multiply that by 360 degrees, and we get 51.3 degrees. So city B is 51.3 degrees south of city A. So because city A is north, city B is to the south, we're going to subtract the 2. So 39 degrees minus 51.3 degrees is equal to minus 51.3, and we get negative 12.3 degrees. That means it's below the equator, so that really means 12 degrees to the south. So it's going to be option D. Question 29A. The time in Brisbane is 4.5 hours ahead of the time in New Delhi. John flew from New Delhi to Brisbane via Singapore. His plane left New Delhi at 11:30 a.m. New Delhi time, stopped for 3 hours in Singapore, and arrived in Brisbane at 9 a.m. the following day, Brisbane time. What was the plane's total flying time? Now, comparing two different time zones, it's actually quite difficult. So we need to convert either the New Delhi time into Brisbane time or Brisbane time into New Delhi time. So I think it's easier to do what I said earlier, which is to convert New Delhi time into Brisbane time. So the plane left New Delhi at 11:30 a.m. and we're going to add on 4 hours and 30 minutes, which is, okay, so adding 4 hours, so we got 12:30 p.m, 1:30 p.m, 2:30 p.m, 3:30 p.m, add on another 30 minutes, that's 4 p.m. Brisbane time. And it's going to land at Brisbane at 9 a.m. the following day. And that includes a 3-hour stopover time. So what we're going to do is we're going to draw a number line to help visualize what's going on here. Now that everything is in Brisbane time, so this 11:30 a.m. is now 4 p.m. and instead of New Delhi time, it's now Brisbane time. So starting off from New Delhi, so I'll put ND here, that's New Delhi. Okay, this is midnight, so that's 12 a.m. Okay, so from 4 p.m, 12 a.m, it's going to land at 9 a.m. the following day, arriving in Brisbane. So how many hours have elapsed? So from 4 p.m. to 12 a.m, we have 8 hours. So there's 8 hours there. Then from 12 a.m. to 9 a.m. the next day, there's another 9 hours. Okay, so the total flying time is equal to 8 hours from 4 p.m. to 12 a.m. plus 9 hours, 12 a.m. to 9 a.m. But then we need to subtract this, stopped for 3 hours in Singapore. Okay, this is to get all 3 marks. Okay, so that's equal to 17 minus 3. So total flying time is 14 hours. Question 5. The Coordinated Universal Time, UTC, of Auckland is plus 12 hours and the UTC of Chicago is minus 5 hours. When the time in Chicago is 2 p.m. on Thursday, what is the time in Auckland? Now clearly Auckland is plus 12 hours ahead of UTC, which in the old terminology is Greenwich Mean Time. So Auckland is well ahead of Chicago. In fact, if you were to draw a quick number line, okay, there's 0, which is our UTC. Auckland is 12 hours ahead of UTC. Chicago is negative 5 hours behind UTC. The difference between negative 5 and positive 12 is 17 hours. That means that Auckland is 17 hours in front of Chicago. So if it's 2 p.m. on Thursday in Chicago, adding another 17 hours to that will give you the time in Auckland, will actually be on Friday. So in actual fact, the only option that has a Friday in it is option D. So it's going to be 7 a.m. on Friday. Question 20. City A is in Sweden and is located at 58 degrees north, 16 degrees east. Sydney in Australia is located at 33 degrees south, 151 degrees east. Robert lives in Sydney and needs to give an online presentation to his colleagues in City A starting at 5 p.m. Thursday, local time in Sweden. What time and day in Sydney should Robert start his presentation? It is given that 15 degrees equals 1 hour time difference. Ignore daylight saving. The time difference between two locations is based on the difference in their longitudes, not their latitudes. So we'll consider the longitudes of City A and Sydney. The longitude of City A is 16 degrees east, and the longitude of Sydney is 151 degrees east. And the further east a location, the further ahead in time it is compared to any locations to the left of it or to the west. This can be visualized on a number line where 0 degrees represents the longitude of the prime meridian. West is to the left, east is to the right. City A is 16 degrees east and Sydney is 151 degrees east. Now the difference in longitude is 151 degrees minus 16 degrees, which equals 135 degrees. And it is given that every 15 degrees difference in longitude is equivalent to 1 hour time difference. So the time difference is found by taking 135, dividing it by 15, and that gives 9 hours. So Sydney is 9 hours ahead of City A. Now the time in Sydney is found by taking the time at City A, which is 5 p.m, and notice that 24-hour time is being used, and adding 9 hours to 5 p.m, that equals 2600 hours. Now that doesn't make sense since the time goes from 0000 to 2400. So this means that this is 2 hours past midnight in Sydney. So interpreting this result, this means that Robert should start the presentation at 2 a.m. on Friday in Sydney.